Hey guys, Mr. Kruger here, working on the similarity review worksheet. And I know what you're thinking, we did similarity before we even jumped into right triangles, and you're completely correct. So what we saw as math teachers is that in the March and April standardized testing that you guys are going to be taking, there's going to be a lot of similarity and a lot of trigonometry in terms of right triangles. What we're going to do is in 2 weeks, not the week we come back, but the week after, we're going to test you on both similarity and right triangles. So what this review is going to cover is old material, and I hope a lot of it seems familiar. So I'm only going to pick more of the tougher problems, but this is a review sheet that we have done, but now I'm going to work through some of these types of problems to refresh your memory on what similarity means. Okay, so let me pick a few problems here. So question 1, 2, 3, and 4 are all proportions. Okay, I'm going to work on questions 2, 3, and 4 because I think those are a little more difficult than the first one. So remember, whenever we have a proportion, it's the equaling two ratios, and we can always cross multiply. And remember, the product is 3 times 2x, which is 6x, and 5 times 17. And now we do not divide, we always set them equal to each other. Okay, you set the two products equal. That's very key because a lot of you guys like to divide them automatically. Not always work that way. So now I'm going to divide by 6, and you know what? That's not divisible, so I can leave it as 85 over 6. Okay, the second problem, it looks really difficult, but I promise you it's the same property. So I'm going to write it out here over here so I can get some more space. And you'll see why. Same property, two ratios equal to each other, so I need to cross multiply. Now I'm going to take the extra step so I can see what that looks like. But you guys do not have to if you can distribute in your head. Because some of you guys forgot to distribute the 2. So I have to distribute the 6 and distribute the 2. So I get 6x minus 18 equals 2 times x plus 2. Now what I want you to know is that first step is exactly the same on questions 2 and 3. I'm multiplying the cross products. And then I'm setting them equal to each other with this equal sign right here. Okay, now I'm just going to solve the equation. Subtract 2x from both sides. So I get 4x minus 18 equals 2, add 18, and I get 4x equals 20, divide by 4, x equals 5. Okay, let's finish up with question number 4. Okay, question 4, I know it looks as simple as question 1 and 2, but what you'll see is, watch what happens when I get x times x. I get this x squared, and then 16 times 4 gives me 64. And now I have to square root both sides because that's what happens when you undo a square. You have to square root both sides. And whenever I square root, I get a positive or negative 8. Now, if you think back to when we dropped an altitude from a right triangle, we didn't get positive and negative because that's when x was for a side length. In this case, it's just an algebraic equation. So you have to remember these positive and negative answers. Okay, let's move in here. Questions 5, 6, and 7. Tell whether these two triangles are similar given the information. Give the postulate or theorem that justifies your answer. Okay, so I'm going to mark up this picture because I know that there are 3 methods to proving triangles similar. Angle, angle, where 2 angles are congruent, 2 pairs of corresponding angles are congruent. Side, 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 because the corresponding sides are proportional. And side, angle, side, with the included angle congruent. So let's mark it up. A is congruent to D, and F is congruent. Oh, I made a mistake there. F is congruent to C. Well, all I need is 2 angle angles, so there we go, angle angle postulate. Okay, let's check out the next one. AB over EF, BC over DF, and AC over DE. Well, this is saying that all 3 pairs of corresponding sides are proportional because the ratios are equal to each other. So absolutely, side-side similarity. That's this little similar symbol. Good. The last one, AB and DE. So this is AB, this is DE. And then we had BC and EF. Okay, so I have 2 sides. This is looking good for side, angle, side. But then it gives me angle C and angle F. And remember that side, angle, side only works if this angle, focus right here, if this angle right here was between the 2 sides given. So if I was given E and B, side, angle, side would work. But because it's not similar right there. Okay, next problem. Are these 2 triangles similar? Well, remember, I'm only given side lengths, so I can use proportions to figure out if they are. Smallest to smallest. So let's set up 18 over 24. Then medium would be 24 over the medium side from the bigger triangle, which is 32. And then the biggest side over the biggest side. So right now they don't look really equal to each other, but let's simplify some fractions. 18 and 24 are both divisible by 6, which gives me 3/4. 24 and 32 are both divisible by 8, which gives me 3/4. And 27 and 36 both divisible by 9, both divide them both by 9, and I get 3/4. Well, there we go. They are similar. by side, side, side postulate. Okay, we're going to skip number 9 and move down to this bottom one here, question 10. If this quadrilateral is similar to another quadrilateral, then AB over EF equals blank over FG. Well, just like triangles, the order of the letters matters. Okay, all corresponding angles are in the same position, meaning first position, second, second, and so forth. And same with sides. The first two letters are proportional to the second two. The second two letters are proportional to the second two. The third two letters and the third two, and so forth. The first and the last, like AD and EF. So let's take a look here. AB and EF are corresponding. Perfect. So now we need to figure out what are the two letters that are corresponding to FG. Well, if they're the middle two letters, then that means the middle two letters have to be proportional. So BC. Okay, let's look over here. Given these two triangles are similar, remember that the location matters in the terms of letters. Find the missing measure. Well, I'm only given 3 of the 4, so I need to set up a proportion. Well, AB are the first two letters and DE, so we can set them up into proportion. 16 over 10, or sorry, over 10 right here, because AB and DE. Then BC are the second two letters, and EF are the second two letters. So we can set BC, which is 8, over X, because that's what we don't know. So now we can cross multiply. So we get 16x equals 80. The cross products are equal to each other. And let's divide this out, see what we get. Comes out to be 5. So x equals 5. Remember, we're solving for the length of EF, so EF is 5. Okay, I do want you guys to take a look here. Okay, determine which two of the 3 given triangles are similar. So if I go from CBA to FDE, that's these two smaller triangles right here, CBA and FDE. 6 minus 2 is 4, 12 minus 10 is, okay, 6 minus 2 is 4, 12 minus 2 is 10, 10 minus 8 is 2. 10 minus 2 is 8. Well, that's great if it was subtraction. Remember, scale factor is always multiplication. So let's try the medium to the big. Plus 4, times 2, and times not exactly 2. So we can't get from CBA to GHI. So the last two, the small and the big. 4 to 10. I don't know what that is. 10 to 25. 8, 20. I can't really figure this out in my head, so let's write out a proportion. Smallest to smallest, so 4 over 10. Medium to medium, so 8 over 20. And 10 to 25, big to big. Let's simplify these. 2 goes into both 4 and 10, so we get 2 fifths. 4 goes into both 8 and 20, so we get 2 fifths. And 5 goes into 10 and 25, and we get 2 fifths. Boom. So we know that FDE is similar to GHI because the sides are proportional. Remember the similarity statement. This was threw a few of you guys off during the test. Similarity statement says that this triangle, and let's start from top F, D to E. So let's use those letters in that order. F, D, E is similar. And then triangle again. In the same order, we're going to go from G, H to I. Okay, last part right here at the bottom. We're going to try a few of these, and you'll see how it looks. I'm going to use my highlighter here. So AB over BC. So this part to this part, okay, is equal to GF. So this part, and then following that order, just like AB was left to right, GF will be left to right, so FE. Let's try this 14. AD, which is this big side of the big triangle, over GD, which is the big side of the big triangle, is equal to, double blank. So, if I'm going the top side to the bottom side, let's go the top side of the medium triangle to the bottom side of the medium triangle. So we got BD over the bottom side, which is FD. You could have also used the small triangle. Let's try one more here. AG, which is this big side of the big triangle, or actually the small side, the vertical side of the big triangle, over CE of the small triangle. So now we need a side of the big triangle, maybe AD, and then the corresponding side from the small triangle over CD. So it's big triangle to small triangle equals big triangle to small triangle. So we got AD to CD. Okay, so they always follow that pattern. Big triangle, small triangle, medium triangles, corresponding sides, however you figure it out. Let's go to the second page here. Okay, so let's pick a few of these. I know for sure we might not see a problem like this. Let's go to 23. You saw this on this quiz, okay? 45-foot tree, cast 30-foot shadow, so we can always go 45 over 30, both dealing with the tree. But remember, it is, let me talk about it a little. Okay, so 45 is talking about the height, and 30 is talking about the shadow. So remember, we talked about this over and over and over again. We have to have height over shadow. Nearby building that casts 150-foot shadow. Well, shadow's in the denominator in the first ratio. It has to be the denominator second. How tall? So that's a height. That's what we're solving for. If you don't believe me, we got height over shadow again. So we know we set it up correctly. Let's cross multiply here. 30x. Remember, we set the products equal. 45 times 150 is going to be a big number. Here we go. 45 times 150 gives me 6,750. Divide both sides by 30 and we get 225 feet for the height of the building. Okay, let's try this next one right here, 24. The scale model of an airplane is 13 inches. The scale model is 1 to 420. So we're saying that it's 420 times as big as the scale model. So the first thing I can do is I can take 13 times 420. Okay, and if I do that, let's say I don't even want to use that. Let's say I want to actually use a proportion. Okay, I'm fine with that. So here we go. If the scale model is 1 over the real airplane, which is 420, then we have to do scale model in the numerator over the real airplane in the other ratio. Well, we know that the scale model is 13 inches, and we don't know the real airplane's length. And there we go. This works as well. X times 1 is X, and 13 times 420 equals 5,460. Okay, so, but now it says the nearest foot. Remember that there are 12 inches in a foot, so I'm going to divide by 12. And that's going to tell me that we have 455 feet for the actual airplane. Okay, question 25 is actually very similar to the problem that we did on the front in terms of setting up a proportion to find the missing side lengths. Let's try a few more down here. For all these, we need proportions besides question 31. So I'm going to pick, let's go 27, 28, 29, and 30. Here we go. 27. There's multiple ways to set this up, so let's just start with any proportion and then we'll align the other ratio to it. So I'm going to go from outside of this big triangle right here to 20 over the other side of the big triangle x. So 20 over x. So I went from outside to inside, so I need to go from outside back to inside of the small triangle. So 7 over 2, and now I can cross multiply. So I get 40 equals 7x, divide by 7, divide by 7, x equals 40 over 7. Let's go to 28 here. Okay, notice how 9 and 5 are both little parts of the big side. And notice how 24 is the full length of the big side. So that means that I need to add these up to get this 14. And now I have full sides of the big triangle. So let's go small triangle, which is 9, over big triangle, which is 14. And corresponding side over here, small triangle, which is x, over big side of the big triangle, which is 24. So notice how I went from small triangle to big triangle equals small triangle to big triangle. Okay, cross multiply, cross multiply. So I get 14x equals 216. Divide both sides by 14. That's not pretty. So let's just keep it as fraction form. 216 over 14. If I want to divide both the numerator and denominator by 2 so I can simplify this fraction, I get 108 over 7. Okay, let's go down to question number 29. Okay, let's focus on what we have here. We have a side of the big triangle and a piece of the big triangle. And now we have a side of the small triangle and a piece of the big triangle. So 16 and 12 for sure line up, but 28 and x are not corresponding. So you know what, if we have this side of the small triangle, let's try to find the other side of the small triangle. Well, if 16 plus some number equals 12, let's subtract that from 28. Okay, well, I just gave it to you, it's actually 12. Okay, so now what you'll see in the picture is that we have the side of the small triangle on the piece of the big triangle, corresponding side of the small triangle, piece of the big triangle. Now we can set up this proportion. So 12 over 16 equals x over 12, which you'll see right here, small triangle, or piece to piece, top to bottom, equals top to bottom. Cross multiply, get 144, and we set them equal to each other. Equals 16x, so 144 divided by 16, that gives me an integer which is 9. Okay, we're going to do one more together. Here we go. So I have, let's focus what we have here, a side of the big triangle and a side of the small triangle, a piece of the big triangle and a side of the small triangle. I need corresponding sides. The corresponding side to 32 will be the sum of 8 and 12, so that's going to be 20. Right, if I want to set up a proportion with both corresponding sides, and 32 is an entire side of the big triangle, then I need an entire side of the small triangle. So now we can set this up. Let's go big triangle over small triangle, 32 over x equals corresponding sides of the small triangle, big triangle to small triangle. So that's going to be 20 over 12. And now I can cross multiply. So I get 32 times 12 equals 384. Equals 20x, divide by 20, divide by 20, and 19.2, we could keep it as a fraction if you want to. 384 over 20 equals x. Is 384 divisible by 4? It is, so that I can divide both by 4, which will give me 96 over 5 equals x. Okay, down to the bottom with the last few problems, dilations. Okay, remember dilation is the only transformation that will give us similar figures. Okay, that's why this is part of the similar triangles. So let's pay attention here. There's two letters. There's P prime and P. Remember that P without the prime symbol is the pre-image. That is before the transformation. Where with the P prime, it is the image after the transformation. Okay, so to find the scale factor, you always take after the transformation, CP prime divided by the original, which is the pre-image. Okay, so let's try that out. C to P is actually, or sorry, CP prime is this 4. This is after. And then we're going to, the pre-image, which is CP, which is before the actual transformation, is 20. Okay, if I simplify that fraction, I get 1/5. And if you'll notice, that scale factor is 1/5, which you know must be a reduction because it's less than 1. And remember, the only way for it to be an enlargement is if the scale factor is greater than 1. But what I want to point out is, here's the original shape. Notice how big that is compared to after the transformation, so you know it must be a reduction. Okay, so you can always look back to the picture to see if you're doing it right. The next one right here. CP prime, here is before the transformation, here is after. So we're looking for an enlargement. We are looking for a scale factor that is greater than 1. So I always take after the transformation, which is 15, and I divide by the length before the transformation, which is 5. A lot of you guys try to find this 10. That's good information that this is 10, but that's not the information I need. I need the entire length of after the transformation divided by the entire length before the transformation. So this simplifies to 3. So my scale factor is 3. And that's greater than 1, so that's why we know it's an enlargement. Okay, so I hope this refreshes a lot of memories about last chapter. Take a look at all this work right here and know that you guys can do all this stuff. Okay, so take a look back here, look back at your trigonometry quiz review. So 2 videos, about 30 minutes. I know that's a lot, but the test is not for a week and a half. So break this up, try it parts at a time. I promise you guys can get this. Good luck.